Alright, so here's a video on mixtures. If you did not yet check out the video on elements and compounds, you should do that first. It just makes a little more sense to cover that information before we talk about mixtures. So when we talk about mixtures, there are actually three different classifications of mixtures that you need to be familiar with. There's some mixtures that are called solutions, there's mixtures that are called suspensions, and there's mixtures that are called colloids. And we already discussed when we were talking about chemical and physical properties, we talked about ways that we can separate a mixture based upon physical properties. And these are those same methods apply to separating a mixture, because mixtures can be separated only by are separated by physical means as opposed to chemical means. So things like filtering, sifting, magnetism, evaporation, distillation, sorting, the use of a centrifuge. These are ways that you can separate a mixture into their own separate components. So again, mixtures, there's really three types. Solutions, which like salt water is an example of that. A suspension, which would be something like Italian salad dressing, or even the salad itself is a suspension. And then things like colloids, which are things like gelatin. They kind of are the middle player here between solutions and suspensions. So talking about solutions in particular, just some general features that make something considered a solution. These are mixtures have very, very small particles, and these will not filter out. So there's something called filter paper, and if you pour a solution like salt water into the filter paper, even the salt and the water will both go through the filter paper. So what comes out on the other side from the filter paper will be still salt water, just like what you poured into it. So that's what we mean when we say these will not filter. You won't be able to separate the salt from the water when you pour this through a filter, through filter paper. So solutions do not filter, and they do not scatter light. So scatter light means that when light hits the substance or particles, it bounces off in lots of different directions. This doesn't happen with a solution. Light will pass directly through without any of the particles of light or the parts of the light changing direction. So when light is passing through, if you have a good solution of pure salt water, distilled water, and salt, light should pass directly through it. If we were to put like a laser pointer into the container of light, you wouldn't even see the beam of light from the laser pointer in the water. The salt water solution, it would be passing right through. We call these mixtures homogeneous because they're the same throughout. So that prefix homo means the same. So these look the same throughout, and they taste the same throughout, and they have the same ratio of parts throughout the entire mixture. Those are solutions. On the other end, we have suspensions, and suspensions are kind of the exact opposite of a solution. These have very large particles. They will be able to filter the components out if you pour it through filter paper. These do scatter light, so if you shine light through it, you could see the light bouncing off in different directions. You'll be able to see the beam of light through it. And these are called heterogeneous because these are not the same throughout. They look different. If you were to take sampling, if we're talking about Italian salad dressing, if we were to take samplings from different area of a bottle of salad dressing, you're going to have different components or different ratio of the components in different locations. So like you might have more or less oil or vinegar. You might have more or less like pimento and tomato and onion, different Italian seasonings that are all mixed in different locations. If you took 4 or 5 different samples from a bottle, each sample would have different ratio of the components, but all should still contain the components. So that's a suspension. And these are probably most of the mixtures you really deal with on a day-to-day basis are going to be suspensions from what you're typically thinking of. Now, colloids are probably the ones that are hardest to identify or hardest to think about. Colloids, like Jello, for instance, have medium-sized particles, so they're like in between a suspension and a solution in terms of particle size. They will not filter, which is something they have in common with a solution, but they do scatter light, which is something they have in common with a suspension. We don't really worry about classifying these as heterogeneous or homogeneous because it really depends on like how big a scale do you want to look at. Just from a grand scale look, you would think that these are pretty homogeneous, but if you get closer and closer and closer and looking in like a really high-powered microscope, you might find that they are in fact heterogeneous. So we don't really worry too much and get hung up on whether these are heterogeneous or homogeneous. We just want to worry about the other two with that solutions are homogeneous and suspensions are heterogeneous. Now, we need to talk more about suspensions, or rather, I'm sorry, solutions. So I'm going to have a separate video just dedicated to solutions, so make sure you come back and check that out.